Hello! Everyone's talking about AI and what it is or is not good for. Well, here's an example of how AI can help improve a website's SEO and user experience, both for people using assistive technology and for those who don't. Here we'll see how to extract data in a JSON structure from either ChatGPT or Anthropic about what is contained in an image, but with a specific focus and goal of improving SEO and screen reader experience. Let's go through it. The post using AI to boost accessibility and SEO is over on the fly.io Phoenix Files blog. The implementation details here are actually in Elixir, but the principles are the same for anything that's using a LangChain-like library for talking to AI. It's generally applicable. So let's get in. In the fast-paced world of digital content, the adage, "A picture is worth 1,000 words," still is as true as ever. And this is the case for Sarah, a content manager at a popular online magazine. She is racing to finalize a feature called The Hidden Gems of Urban Street Art, a visually rich showcase of Toronto's vibrant but oft overlooked urban art scene. And as the deadline looms near, she faces a dilemma. How do we ensure that these compelling images are not only eye-catching, but also accessible to all readers and at the same time optimized for SEO? Here's an example of the photo from Sarah's feature article that needs a description for accessibility and SEO. It's pretty striking, right? Like that's a pretty cool piece of artwork there. It'll be interesting to see how AI can handle something like that. We've been tasked with solving this recurring need, the need for content-aware alt tag descriptions and caption text for images that accompany an article. Context-aware means that the description should relate to how the image is being used and not simply a description of the image. And with these two versions of an image description, an alt tag and a caption text, we improve both SEO, which is search engine optimization, and the accessibility of our content. So we're turning to AI to help automate the process and bulk process hundreds or thousands of past images as well. Our job is to use AI to create decent alt tag and caption text on hundreds or thousands of images. For the AI, we'll leverage both OpenAI's ChatGPT and Anthropic's Claude, LLMs. These are large language models, and we'll be using the Elixir LangChain library to perform AI analysis on the images. The same process can be applied using other languages and tools. It's mostly what we're getting into is the APIs that we need from the LLMs and the prompts that we're going to be using to do it. Let's first understand more about what makes high-quality image description text so we know what we're aiming for. In this case, context matters. How the image is being used matters. The usage provides additional context for how the images should be described. Let's consider the following image when used in different contexts. So if we have this image and there's just describing the image with no other context, you might say, an elderly man sitting on a bench by a lakeside reading a book with mountains in the background. That's correct. But if it's in the context of a story about a local author, then we might describe it differently. We might say, René Favre reading beside a serene lake with misty mountains in the background, right? So we're highlighting a specific person. The context changes how we describe the image. Another one, description in the context of a travel destination. It might say, older man sitting on a bench overlooking Lake Lucerne with mountains in the background. So that's a very specific Swiss destination. So you can see how the context impacts what the right type of alt text should be, which is both important for screen readers and assistive technology, but also for SEO. How the image is used changes how it should be described. This impacts what aspects of the photo should be called out as relevant or ignored entirely. Okay, for the description needs in the context of our article, what are the current best practices around alt text and captions? So what is alt text, right? We're just going to cover this quickly. Alt text or alternative text describes the images in HTML code. It is essential for two main reasons. Accessibility. Screen readers use alt text to convey image content to visually impaired users, ensuring that everyone can fully engage with the web page. SEO. Search engines read alt text to understand and index images, enhancing web page visibility in search results. So in a nutshell, alt text makes images accessible and boosts their discoverability, benefiting both users and search engines. When we make our content more accessible to users and search engines, it benefits us. So what are captions? The figure and fig caption are semantic HTML5 elements that work together to provide context and captions for images, diagrams, and other media within a web page. The Mozilla documentation encourages us to use semantic HTML elements over ARIA tags whenever possible. ARIA tags is accessible rich internet applications. It's another standard that screen readers use. And just quoting from the Mozilla docs, if at all possible, you should use the appropriate semantic HTML elements to mark up a figure and its caption using fig and fig caption HTML elements. In HTML, this is what it looks like. You can see that there. On the web page, the default styling places the caption below the media, although this can be modified through CSS. Like you'll see where maybe on hover, it'll display the caption over like an overlay on top of the image, or just it's always present there on the image, or you can style it, right? We have more freedom with the content displayed in a fig caption. The only rule is there can only be one per figure. It is self-contained with the media it describes, making it more portable within a page. It's easy to pick it up and move it around in a page if you're reorganizing stuff. And a general recommendation is to connect the media to the page, providing context for why it is there. So again, context matters. Lastly, keep in mind the visual display of the fig caption's contents and make the text concise. Don't put in multiple paragraphs, right? That's a bad experience for everybody. In a nutshell, figure and fig caption provide visual captions and context to sighted readers, assistive technology, and search engines, effectively connecting media with the surrounding article or content on the page. So, how can AI help us here? AI can analyze an image and provide a text description. Recent model improvements from both OpenAI and Anthropic make this much easier and more powerful. However, unless we want the AI to run amok and wax poetic on one image and do something completely different on the next, we need to provide a set of constraints and instructions that will get us what we want. In other words, prompt engineering, woohoo! To get consistent, well-performing text, we need to understand a bit more about what makes for good alt text so the AI can give us exactly what we need. This is a list of the relevant recommendations for alt text. So I learned some interesting things with this one. Concise description. Keep the alt text concise and to the point. Aim for a simple sentence or a fragment that contains the essential information about the image. Typically, 125 characters or less is advisable, as some screen readers may truncate longer text. So just think about that as a user of assistive technology. If someone's putting in a large paragraph in an alt tag, it just stops reading it. And that might actually be a better experience for someone using assistive technology, for that use case. So we want to make sure our alt text is short. And content relevance. Focus on the information that the image conveys and its context within the page. Describe what is relevant to the content and functionality of the site. If the image contains text such as a logo, include the text in the alt tag. In this case, we're not actually dealing with text. Avoid redundancy. Here's another rule for our use case here. Do not include phrases like image of or graphic of, as screen readers often provide this context to their users. This can be redundant and unnecessarily verbose. And context matters. Tailor the alt text depending on where and how the image is used. The same image might need different alt text in different contexts, and that's what we looked at before with the man sitting by the lake. Localization. When dealing with multilingual sites, make sure to translate the alt text appropriately, keeping the same considerations in mind as for the original language. And actually, we're not going to get into it in this article, but AI is actually quite good at coming up with the translated version of that same text. And use proper grammar. Even though it's brief, ensure your alt text uses correct spelling, grammar, and punctuation. This improves clarity and the overall user experience. AI is actually pretty good at that too. Better than I am most of the time. AI can help with all these points. This dramatically simplifies the task, especially when we need to provide descriptions, text for many, many images. As for the fig caption text, we have more freedom with that. It's like these are the specific rules that are recommended. And I have resources linked down at the bottom where this comes from. but there aren't so many restrictions or recommendations around fig captions. So we have more freedom with those. Still, you don't want to be too long because it's just a bad experience. But like a short paragraph, maybe 1 to 2 sentences or something like that. But as for the fig caption text, we have more freedom with that, and we'll try to pull in more context from the article. It'll be fun. All right, now we're into the AI part. So we understand that the context matters, and we have the guidelines for how the alt text should be generated. We're ready to write code. To send an image to both OpenAI and Anthropic, we'll base64 encode the image and submit it that way. In Elixir, the process looks like this. Just reading the image off the disk and base64 encoding it. I'm sure there are many different ways to do that in every language. Let's start with OpenAI's ChatGPT service. We're going to use model GPT-4o for the image abilities that we want. So in the Elixir library we're using, that's what we do. We just specify the model that we want to use. Next, we'll set up the messages we're sending to the LLM. This is the prompt engineering part. In the following code, notice that the system messages provide the general context for what we are doing and what we want from the LLM. The user message is made up of 2 parts. A prompt template supports variable replacement tags using EEX templates. This allows us to easily customize the prompt for each image as we process through a whole batch, and this turns into a content part. So that's a specific implementation, but with like the JavaScript or Python LangChain library, same thing, prompt templates. It's just a way of substituting in things to our prompt. And a content part makes it easy for us to provide our image directly to the LLM. All right, we provide the LLM with the context for the task in the system prompt, specific instructions about an image, and an image to analyze with a vision-enabled model so it can perform the task. And if we just kind of look over what we got here, like our system prompt is, we're telling it that it's an expert providing image descriptions for assistive technology and SEO benefits. So we're priming it for our purpose. The image is included in an online article titled, so this is where we're pulling in what the context is of what we care about for this article and why we're doing this. The article aims to showcase the vibrant and often overlooked artworks that adorn the nooks and crannies around the city of Toronto, Canada. And we're giving it instructions. We want HTML image alt text and HTML figure and fig caption text. And then we're giving it some more specific rules. This is just in a markdown format. Alt text format, briefly describe the contents of the image where the context is focusing on the urban street art. Be concise and limit the description to 125 characters or less. So this is where we're starting to pull in some of those recommendations and best practices into our prompt. And then we give it an example alt text because we want a consistent performance on one image to the next image to the next image so that we're not getting like a completely different feel from one image to the next within the same article even. So we provided an example of one that meets all of our requirements. It's the shortness, length, and calling out things the way we want. And then we give a fig caption format, image description, focusing on the artwork, providing a description of the appearance, style, street address if available, and how it relates to the surroundings. Be concise, right? So we're giving it, it's going to pull in more information. We have a little bit more freedom there. And then our example caption text. So we have an example for that too. Then our user template. That's our user message here. We're going to template this in, provide the description for the image, incorporate relevant information from the following additional details if applicable. So this is where you imagine we're walking through a database records of these are all the images that we have. They've been uploaded, they're recorded somewhere, and maybe we have a little bit of EXIF information, or it's already been captioned in some way that we have some information about what image this is. That's where we're going to pull in that information and template that into what we're sending to the LLM. And now finally, we're giving it the instructions on how we want the data to be received and returned back to us, that we want it in a JSON format that has 2 keys, an alt with the generated alt text and a caption with the generated caption text. That's it. And just something else to highlight, when you're sending an image to something like OpenAI, ChatGPT, it will tile and break up a large image into small chunks and analyze those in pieces. And we don't really want that. And we're not looking for that super granular, like find Waldo, like where's Waldo in this photo? We're not doing that. So we say we have to tell it what format it's in so it knows what to expect, and we're giving it a JPEG. And that we say low here to say, if you have to scale the image down that we're giving you, that's fine. Just look at it as a whole. That's all that is doing for us. So just continuing, make sure the media option matches both the image and what is supported by the LLM you're working with. Yes, like you can't upload an image format it doesn't support. The use of the prompt template in the user message, we covered that and how that's going to be pulling in data from like another system. And JSON output. So just covering that. For each image, we want 2 pieces of generated content. To make this easy on ourselves, we instruct it to put them in a JSON object because we want it to be machine readable, machine accessible. And so we have alt and caption. We already covered that. To make working with that output easier, we'll use a JSON processor for processing the messages from the LLM. It has the added ability to return a JSON formatting any errors that we get in the formatting. Like sometimes LLMs are not very good about the JSON they give you. It might be invalid. So this will automatically process it and say, if it's not valid JSON, I'm going to return an error to the LLM, have it fix it, send it back. So that's what the JSON processor is going to be doing for us. So we'll see that all put together in the next. And making the request. Everything is ready to make the request. We have the image we've set up with the LLM we're connected to. We provided the context in our prompt and instructions for the type of description we want. Next, we'll submit the request to the server and review the response. For this example, the image data from other system, which we'll see in a second, is a substitute for a database call or other lookup for additional information that we might have on the image. So in this case, we're faking it out that we pulled this from another system where the information we have about the image that's being examined is image of urban art mural on underpass at 507 King Street East. So we have some very specific information about that image, and that's coming from an external system. So we're going to be incorporating that. And when we're pulling it all together, we're just saying I have the LLM, which is using our OpenAI chat model. And we are going to start up a new chain and apply the prompt template, which means we're taking that data that we're pulling in and substituting that into our message so that becomes part of the user message. And that's stuck in right here. That's it. And then we have a message processor that we're expecting it'll do the JSON processing for us. The mode is run until success, which means if it's giving us invalid JSON, return an error and let it run again until it actually gives us a good valid response, or it's going to stop after it fails too many times. All right, let's keep going. Notice that when running the chain, we use the option mode until success. Some LLMs are better at generating valid JSON than others. If you've ever tried like Llama or something like that, or some of the other smaller, more experimental ones, you'll experience this. And when we include the JSON processor, it parses the assistant's content, converting it into an Elixir map. The converted data is stored on the message processed content. So that's what we're going to be getting here, is printing out the processed content. And if the LLM fails to give us valid JSON, the JSON processor generates a user message reporting the issue to the LLM. The until success mode makes repeated calls, round trips, requests to the LLM, allowing it to correct any errors, but don't worry, it won't run forever. The LLM chain's max retry count gives up after X number of failures, and the default is 3. So here is a sample of what was generated when we ran it. And on that, so remember what image we're talking about. We're talking about this image. This is the image that's being described. And so now we're asking OpenAI, ChatGPT, describe that for me. And the alt text it generates, colorful mural of a face under a bridge at 507 King Street East, right? It's perfect. It meets all our requirements. It's less than 125 characters. It's pulling in relevant specific data about that image, but it's within the context of what we care about in our article, and it's doing a perfect job. The caption text, a captivating face mural under 507 King Street East underpass, featuring vivid hues and expressive eyes. The art adds a pop of color to the urban landscape, drawing the attention of pedestrians as they pass by. Perfect. Better than I could have done. That's the point. It's better than I could have done. Great. We got highly specific image descriptions for both alt text and use in a caption. Even more, it's all written in the context of the article about urban art. Importantly, we got the data back in a machine-friendly format, so that means automation, and our application can easily work with that. We've come this far. Let's see if we can do that with Anthropic's Claude, because Claude also supports images, and they call this, when you talk about working with text and images, they call it multimodal, right? So that's what we're talking about. And so when we set up to work with Anthropic's Claude, all we're doing is we're just saying, hey, use this different model, and it's the model Claude 3 Opus and a date for when they have that model available. So whatever model you pick, just make sure it supports the vision ability, because some of them don't. And the one that's included here worked fine. The code that we're working with looks exactly the same, except we swapped out the LLM chat model to connect with a different, to connect with Anthropic. So it's all the same thing. The only difference is this line right there as we're connecting out to our different chat model. Everything else is the same. What do we get? Our alt text. Colorful street art mural with a face in vibrant colors on an underpass pillar in an urban setting. Also good. Also meets our requirements. Doesn't have to pull in the address, right? We didn't say that the alt tag had to, so it's going to make different choices. It's interesting. But the caption text has a little bit more freedom, and it does. It says, a striking urban art mural adorns an underpass pillar at 507 King Street East. The artwork features a mesmerizing face composed of vivid rainbow-like hues and intricate patterns, framed by the industrial yellow beams above. The mural transforms the concrete structure into a captivating focal point for passerby. Better than I could do. Seriously. Maybe you just don't know my lack of skills in that area. All right, nice. The Elixir LangChain library abstracted away the difference between the two services with no code changes. We just swapped out the model we're using. So we can make a similar request about an image from Anthropic's Claude as well. And that's the case with any, using a LangChain library or any other library like that. The whole point is to be an abstraction. So discussion, let's just wrap it up. That's a lot. Let's recap the main points that we learned. Both OpenAI's ChatGPT and Anthropic Claude models can interpret the meaning of images. AI can create pretty good image descriptions that are context aware. AI can incorporate image-specific descriptions to make the description hyper-specific, like pulling in the address information that we had about that particular image and injecting that in. AI can return the text descriptions in multiple formats. So we saw how, in one request, we're getting back alt text and caption text in one request. AI can also be used to batch process thousands of images if needed. So that's the whole thing about the automation part, right? We could just do our whole back catalog this way and just, stick this out in there and it becomes part of our content management system, which we'll get to in a second. And the other point that we covered that we want to touch on is that AI libraries can abstract away the differences between services, making our code less dependent or brittle on any particular service. So if one of them becomes too expensive or is not available at some time, or we just want to alternate between the two so we're never overly dependent on one, that's what these libraries are for. There are limits to what AI can do. AI won't always perfectly interpret what's in an image as well as a human can. However, it can be done much faster, automated, and performed on more images than is humanly possible in that given time frame. And in many cases, that means we get good, if not perfect, context-aware alt text where we may otherwise have none because we don't have the people nor the time to manually do the work. And that's the key. A skilled human would do a better job, but if we don't have that, and the alternative is we have poor quality or none, then this is much better and it can be automated. That's the point, right? We can get something quite good and quite cheaply and automated. And so finally, this feature would likely end up being built into our content management system or CMS. In our fictitious scenario, that's probably what we'd end up doing, building this feature into a company's software. But now that you've seen how you can do it yourself, sweet. So final thoughts, AI made our visual content more accessible to people using assistive technology, and our image content will perform better in SEO. And there are some resources down below where you can check out all the different details and recommendations. But yes, AI can actually do really useful things, and it's not taking anybody's job, because I think it's perfect for those cases where it's like, what do I choose from? I either can't do something, or I can use this to do a quite good job and automate it. And I can build it into my content management system. And then that becomes an awesome default, which a human can then tweak if it's like off. But that's awesome. Just a fun use case how AI can actually be useful, especially with some of the latest models with vision ability to have conversations about visual images, but adding context to it to make it really relevant and useful for us. Thanks for checking it out.